and welcome back to Risk Analytics. We're going to look at a model here which looks at retirement investment model. It's a simulation model, and this is a model which a lot of students enjoy. A lot of you like to mess around with this because it kind of has direct application to your investments, especially if you're investing money into stocks and bonds and things like that. So we're going to talk about how you can figure out how a group of data is, what kind of distribution it is, and use that distribution to make plans for your retirement. My name is Hari Rajagopalan, and I will be walking you through this video. So let's take an example. So let's assume that you are 25 years of age and have graduated from your undergraduate and just completed an MBA, and you've got a really good job right now. Pays you a decent amount of money, and you have finished your finance and accounting classes, and you've learned about Roth IRAs from your finance and accounting class. Now, if you know your IRAs is for your retirement, your traditional IRA, you basically put your money and you don't pay tax on it, so it's what's called before tax income. So you take it out, so it reduces your overall tax burden because it reduces your income, and you can't touch it for some period of time. Your Roth IRA is different, where you pay tax first and then you put money. You can't touch it till you're 60 or 65, and then when you withdraw from that, it's tax-free. That income is tax-free. So there are some limits regarding your income and how much you can put, but we won't get into all that. Let's assume that you're thinking of saving $5,000 a year in Roth IRA, and it's going to be invested in a pure index fund, and let's use S&P 500 index. So savings for 40 years, if you're 25 and you're going to put $5,000 a year, you're going to invest about $200,000 in 40 years. And you want to find out what is the probability of making a minimum of $1 million if you do this for 40 years. Now, Roth investments can be withdrawn without taxes after retirement, as I said. Now, remember, $5,000 a year is less than $500 a month. If you have a decent job, and this is something which is doable. So let's assume you're the youngest in your family. You have a sister who's 30 years old. Your brothers are 35 and 40. So there's 4 of you. And let's assume that they haven't done any of this and now are going to start doing it at 30, 35, and 40. So let's look at, they want to invest the same 200,000 and they start withdrawing it at 65. So let's look at the impact of if you start at 25 versus somebody starting at 30 versus 35 and 40. So the first thing is to actually look at the S&P 500 returns per year, and that's given to you. We have from 1926 onwards to 2020. Here are the returns, S&P 500 returns. And you can see sometimes it's positive, sometimes it's negative, right? And we have here, you have your initial investment. Here's your age starting at 25. Beginning balance is 0. You deposit $5,000. And then you have a return on investment and you have your ending balance, right? So this is $5,000 every year. And the return on investments is some percentage based on this table. It has to fit the distribution of this table. Or you can get the average and standard deviation, just say it's a normal distribution, right? So this fit function is right here, right? And then once you click on the fit function, this will appear, and you can use the existing default, and I'll talk about the fittings once we get to Excel. And it'll show you different distributions and the best distribution which it will fit into. So it has, here you can look at logistics, normal, min, extreme, and so on. So let's go to Excel and see how this is set up and done. So here we have all the returns, and we want to find out what distribution this data set is. And this is not an exact science, but it's something which you'll have to work on and look at the data. one of the first things you can is to look at the data, go to the histogram, and see what kind of data this is. So here we have, if you just look at default histogram, it looks kind of normal, but a little bit skewed to the right, right? So you can, if you want to, click fit here. And once you look at fit options, this is the data set. It is continuous, it's not a discrete. You can allow for shifted distributions. I'm going to not allow, but you can allow for it. You can choose goodness of fit tests, and let's talk about each one. If it's discrete, you can use a chi-square test statistic, so long as you have enough frequencies in each bucket, right? You've got to have a lot of frequencies for chi-square. The Kolmogorov and Smirnov statistics, the goodness of fit is for continuous distributions. And now you can use it for any distribution, and a more refined version of Kolmogorov-Smirnov is Anderson-Darling. Now the AIC-BIC statistic is only for comparative. It compares one distribution to another. It doesn't talk about goodness of fit, but it tells you which one is a better fit. Okay? And since we want to choose one of the many, we can just go ahead and use the one which the AIC-BIC statistic here. So once we click here, the lowest will actually give us the best model, AIC-BIC. Okay, so let's click the fit, and we see here logistic here has a fit statistic of 24.8, which is the AIC. And so it gives us that. If you use normal, if you choose normal, that's a 28.4. So this is not as good as a fit as the logistic, right? And when you click and you switch this off, it'll ask you, do you wish to accept the fitted distribution? And if you say yes, it'll ask you to select a cell where it'll put that particular distribution in. So here is the distribution which you have, right? I've already done that, so it's here. And then you are going to build your model. So you start at 25, your beginning balance is 0, you deposit 5,000. Now, for the return on investment, it's very important that you don't just put equal to. You've got to copy this and paste formula. You got to paste the formula here for all these values. If you just say equal to, then all these values will be the same. Now each year can be different, so you got to copy and paste the formula. And then your ending balance is beginning balance plus deposit. It's the money you have plus 1 plus your return on investment, which is what we have. And then next year is your ending balance is your previous year's beginning balance, right? And once you have that, you can run this all the way up till the point you were 64, or if you want to add 65, end of 65, you can add one more year. Let's go ahead and do that. And in this case, let's remove the PSI output from here, and we have PSI output here. Okay, so this is your this end of year 65, you're going to retire, right? And so you can now run this, and you can see where the data is. Okay, so but since we are looking at only 40 years, let's go ahead and keep the old one. I'm just undoing it. So 25, starting at 25, finishing at 64, in the beginning of 65, you're going to retire. So let's run this simulation. And you can see here, the whole thing is done. We just go back here. Let me go ahead and delete this. And you have the simulation, which is already run. Right here, this is PSI output. And when we run the simulation, you can do 1,000 trials. I've actually increased the trials here to about 100,000. And you can now get data on your average. You make an average of 4.07 million. Standard deviation is for this 100,000 is about 4.8 million. So pretty high standard deviation. Standard error is about 15,000. Your 99% confidence rule is about 39,000. So you're 99% confident that you're going to make between 4.11 and 4.039. Of course, is there a chance you could lose your money? The minimum is negative 6 million. So yes, you could lose your money, but a very small chance. Maximum is about 97 million, which is kind of one of the scenarios where you got really lucky. So your target of 1 million, you have an 84% chance of making $1 million by the time you're 64. But if you start at 30, the same setup. So remember, now you're not starting until you're 30. So your deposit now is 200,000, divided by, you're going to divide it by the number of years you have. So you got to put more. You can't just put 5,000. You've got to add a little bit more. So you're putting more money. And if you run the whole thing, you can see your average is about 2.6 million. So from 99% confidence to getting about 4 million, you're now looking at 2.6 million, right? And you have a 75% chance of making $1 million. If you start at 35, it drops even further. You have a 62% chance, and you're about 1.99% chance of getting about 1.7 million. And if you start at 40, then it's only a 44% chance. So the later you start, the less chance you have of making $1 million, even if you invest the same amount. Compound interest works really well in this situation. All right. So I'm going to stop with this and go back to your PowerPoint presentation to kind of work through some of the examples here. And you can modify this model and do a whole bunch of other things. What would happen if you used a static model and just the mean and standard deviation for return on investment? So what you do is you go to the Standard & Poor, you calculate the mean and standard deviation and use the same value every year, right? Or if you just used PSI normal with those mean and standard deviation numbers, right? So one is a static, other one is actually more probabilistic. How would that change your answer? Go ahead and research what the difference between normal distribution and the distribution that your fit function gave you. Now, if you use shifted distributions, you're not going to get logistic. You'll get something else. Go to Google and look at what these distributions mean. Go ahead and do a search for inflation in the United States for the last 100 years and look at your income, expense, savings, and build a 10-year model, budgeting model for yourself using this, right? Add some probability of, you could have a one-off purchase, like when you buy a house, you spend $200,000 or $250,000, or you're spending $30,000 for a new car. So how would you modify your basic income expense model to add these issues? Remember, that'll be a binomial distribution. These are all things you can do, and you can keep a spreadsheet for budgeting with a simulation and keep updating it. So with this, we finish this basic model, and we'll move on to the next.